Hey, everybody, and welcome back to another episode of Adventures in Machine Learning. I'm here with Eóin Shanaghy and Peter Elger. You guys are the authors of the AI as a Service book from Manning. And yeah, just chatting with you briefly, it sounds like you're also AWS consultants, so you know kind of what their raft of services are. And you're experts in helping people set up AI systems that live in the cloud, which is really, really interesting, and using kind of the pre-built systems that they provide you. Because, I'm not a math whiz that can invent this stuff, and it sounds like you're not either. So, real quick before we get going too far, how do people connect with you all if they have questions once we're done talking?
Yeah, sure. You can get us on LinkedIn or Twitter, or you can mail us directly. We're always open. We have some open source up on GitHub as well, so you can come and take a look at that and message us there as well.
Are you making more than $100,000 per year and just realized that you topped out the pay scale at your current company? And you still want to make more money working on interesting projects for companies that'll pay you more? Or maybe there's just some freedom level that money will give you. Well, let me help. I'm starting a program to help developers move up in their careers using proven techniques and by starting a podcast in order to advance. Right now, I'm only scheduling calls to see where you're at, where you want to go, and how you can get there. There's no sales pitch. You can schedule the call at devchat.tv/nextlevel. Very cool. We'll put links to all that in the show notes. If you want to just drop it in the chat, that's how we get that in there. And let's go ahead and talk about AI as a service, because this sounds like kind of my AI implementation is, somebody else has built this, and I'm just gonna look smart by using it. So what's out there? Let's just start there. What's out there and available for people to use?
Yeah, so there's a ton of services. So I suppose the rationale for writing the book is that both myself and Eóin have been in the software field for more years than we care to remember. And we've both been very excited by the rise of AI technology, but not everybody gets to work on self-driving cars or train image recognition algorithms. But what's very
I was doing all that stuff last week. So
of course you were, man. Yeah, of course you were. Just like me, yeah. But what became very clear at the time we started writing this book, which was in 2017 when we first started writing it, was that the one constant in our industry, and there aren't many constants, but one of the constants is the force of commoditization, right? Everything commoditizes. If you've been a developer for long enough, you'll have seen this. And AI was starting to commoditize then, and is commoditizing further now. So really for us, the aim was to take some of the knowledge that we have of AI and machine learning. We've both worked on various different AI projects in the past, not to the self-driving car level, but to realize that commoditization is happening, and that the technology and the techniques are now within the range of most developers. So we want to provide an engineering guide for those folks as to how they can get started with these AI systems and apply them to their work to solve business problems and problems in their day-to-day work. Over the course of writing the book, the scope and range of AI services available from Amazon, because that's what we focus on, has grown just in the 3 years since we started writing the book. So we had to include some more in there. Eóin, maybe you want to talk a bit about the range of services that are available today?
Mm-hmm. Yeah, sure. I mean, I'd kind of echo what Peter said, and also say, if you're interested in getting into machine learning, and let's face it, a lot of people are, because it's just a buzzword, and you go Googling around for tutorials, a lot of what you'll see is kind of Python tutorials and using TensorFlow or PyTorch, some machine learning framework, and helps you get up and running with deep learning, which is really interesting and really cool. And we all like playing with kind of deep technical toys, but when you actually have to do something real with it, you actually have to figure out how to manage your data, how to run your algorithms, how to deploy that and maintain it. And then suddenly you've got a massive set of tasks on hand. So what we really wanted to do is say, okay, that's really a lot of that kind of field of expertise, doing Python machine learning with those deep learning frameworks. It has its place in a lot of innovation and a lot of academia, but for a lot of business users, or a lot of your 90% of developers just want to figure out how they can actually hook this into their systems.
Uh-huh.
So it's about what can you use off the shelf without having to go writing assembly code, because that's what it's kind of like when you're fine tuning deep learning models. You're down at the depths that 90% of people don't necessarily want to be doing. And, it's not going to be cost efficient to do it that way. At the same time, companies like Amazon and Google and Microsoft, they've got access to massive volumes of data to train and fine tune algorithms. And that's what they use to build things like Alexa. And then they give it to you as a service in terms of Lex or Poly or AWS Transcribe, services for doing chatbots, for doing speech recognition, speech synthesis. And then, there's many other services besides. So you can look at forecast for predictive analytics, personalized for, recommendations. And then you've got recognition for recognizing features of images, features of videos. There's a huge amount of cool stuff you can do there. So I'd recommend for people playing with machine learning, it doesn't necessarily have to be about, getting a GPU machine and spending quite a lot of money, figuring out how to train deep learning algorithms. There's a lot that you can learn, a lot that you can retrieve very quickly by playing around with some of those AWS services.
Makes sense. And it sounds really interesting just to dive into some of these. I will also point out that, and it's not necessarily calling anything out on AWS or anything, but I've over the last few years been invited out to several Microsoft events, right? And they talk about cognitive services, and they offer, I know that I've heard them talk about some of the things that you mentioned. I think Google Cloud Platform and Oracle Cloud also offer some of these same services. So wherever your stuff lives, there's probably some form of this that you can go look at and see what they have to offer. And I've also seen people do multi-cloud or cross-cloud stuff, right? So if you find, they don't have the predictive modeling at one cloud, but they have it over at Amazon, you can actually push your data across the internet to Amazon, let them do what they're good at, and then push it back. And so it's great to just see all of this innovation in this space and go, okay, I don't have to go invent this. I have to kind of have a cursory, or maybe I'm wrong, maybe you do need to have a deeper knowledge of the algorithms, but I kind of have to know how it works and what I want out of it, but I don't have to be an expert.
Yeah, so maybe I'll just, and you're right, okay, but there's a couple of points to follow up on there, right? So first of all, most of the cloud providers have very similar services in terms of like image recognition, natural language comprehension, and so on and so on. They've all got offerings, right? If one provider is specifically ahead in a particular area and you need that, then a hybrid cloud approach is fine. I would just say, just be wary of data transfer costs if you're doing high volume, high scale.
Yeah.
The second
that makes sense. Yeah.
Sure, right? Yeah. But if you have the money to spend on it and you're making money from the solution you're providing, then that's just a business, right? The other thing, you're right about understanding. You don't necessarily have to understand all the gubbins underneath. Sorry, that's a European term for your American listeners. I've never heard. You don't necessarily need to understand how the algorithms work, but you do need to be able to interpret the results. So by that I mean, for example, let's take natural language comprehension. Let's say we're doing something like sentiment analysis. So we feed some text in to a machine learning AI algorithm through an API call. We get a response back. And typically, you're going to get a response back that says it's positive, negative, or mixed, or whatever sentiment. But it's all the key thing it's going to return to you as well is a confidence level on each of those results. So your job as an implementer of these types of systems is to understand the confidence level that you score that you get back and interpret that specifically for your domain. So by that I mean, if you just want it to be generally positive sentiment, and then you can say, well, if it's an 80% score, that's fine, I'll go with it. If it's more mission critical, then you might need to tighten that up. It might need to be much higher positive score before you're prepared to take to allow it to be processed automatically. And how do you handle with the mixed sentiment stuff? Are you going to have some kind of queue system where you punt stuff that is not, below your confidence interval that a human is then going to look at? Right. So it's all about understanding and interpreting the results that are coming back and making sure that you're making the appropriate decisions for the particular business domain that you're solving the problem for.
No, that makes sense. So I guess my question there, because I really appreciate you, first of all, you clarifying these points. How do I go about getting the expertise to be able to interpret the results? Because it seems like some of these algorithms, it's fairly straightforward, right? It'll give you a yes or a no, or it'll give you something really, really clear. But yeah, you're talking about sentiment analysis, and yeah, it's 80% or 70%. How do I know what's good enough? Is it trial and error? Is there some education I can
I think
get somewhere?
It's more about involving the business stakeholders in those decisions, right? So it's like,
okay,
look, we are going, this is what we're going to get back. If we put the confidence level at 99%, then that means we're going to get a whole bunch that need to go for human processing, right? Because it's not good. But if we drop the level down, there's going to be less human processing involved. But what's the upshot of an error, right? So if the upshot of an error is, well, we send a marketing message out, and it might go to like 5% of the wrong people, probably not a big deal, right? But if that's then some kind of contract checking or something like that, then there are deeper business ramifications if you get a wrong interpretation. So it's really a business analysis decision rather than a technical decision, I would say, most of the time.
I got you. That makes sense. That makes a lot of sense. Now, the people that I'm trying to talk to on the show are mostly implementers, right? So they're going, okay, how do I build my thing, right? And you kind of get things started in your book with building a serverless image recognition system. And so I'm a little curious if we can just, for the next 10 minutes or so, just talk about, okay, let's say that this is something people want to build, or maybe there's some other algorithm or system that they want to hook in on a serverless type of system. How do they go about doing that? Like, how do they go about finding all of the pieces and then putting them all together to make this work?
Sure. Well, they could win a copy of the book. I know you have some codes to give away there, right?
Yeah. We're going to do a contest. I'll announce it at the end.
Yeah, sure. So really, I suppose the other thread to what we do as a company and as developers is we're big believers in serverless. And again, that is the march of commoditization is everyone's going to go to serverless. So to get started with serverless, and there's a lot of great tutorials around. There's a bunch of books around you can learn. But really, the key thing is if you can understand how to call an API.
Mm-hmm.
At the fundamental level, if you can call an API and you can understand how to use a framework, so we would use something like the serverless framework.
Yep. I love the serverless framework.
Yeah, it's awesome. Right?
So easy.
Yeah, exactly. Right. If you can do that, if you understand a bit of YAML, you can understand how to use the serverless framework, and you can make API calls, you can get started. It's kind of that simple. Mm-hmm. And most developers would be able to do that, right?
Yeah, one thing I'd point out here is that unlike a lot of machine learning books, we deliberately decided to use JavaScript as the language for the book. And this is kind of against the grain. You're welcome. I'm glad it's appreciated because, it was a surprise to a lot of people that a machine learning book would use JavaScript because Python just seems to be, the lingua franca of machine learning, if you like. Mm-hmm. But, at the same time, there's a lot of web developers out there. For machine learning developers or data scientists, they're probably going to choose a different path anyway. So this is more about like web application developers, Node.js developers, people who are familiar with, full stack developers, making it accessible to people like that, essentially like myself and Peter, because that's our bread and butter for the last decade. So that's why we chose JavaScript. And, I think it was really vindicated in terms of, it's gotten good feedback from the users, and it also hasn't made any negative difference in terms of the applications we were able to build. The AWS SDK works equally as well in JavaScript as it does with Bodo 3 and Python. If you're not going to be doing any of the data analytics yourself, if you're using a managed service, it really doesn't matter which language you're using for your backend.
Yeah, I was actually going to point that out and ask, right, that exact question because, I'm not proficient with Python. I'm sure I could pick it up. I've been programming for 15 years, right? But the reason that I see a lot of people using Python is because it has all these algorithms and, it has the math libraries and stuff that are built in and they're pretty fast. And so at the end of the day, it gets all this work done. But if I'm outsourcing that to a service, then why can't I write the glue code in whatever programming language I want?
The answer is
yeah.
I mean, like with regard to Python, both myself and Owen do a fair bit of coding in Python as well, and I kind of like Python. And you're right, it does have those very efficient math libraries, which are great for data science and machine learning if you're doing it at the kind of lower level.
Right.
But the whole point of this book is to say you don't need to do it at the low level if you want to get business results. There's stuff there for you. You can just call it. And my preferred language just happens to be Node.js and JavaScript, right?
Yeah. Yeah, I grew up doing Ruby and Ruby on Rails, but JavaScript's kind of the next language I would reach for. I was going to joke, you know what? I'm going to go ahead and write the glue code in Eiffel or something. But, anyway.
You can if you want.
Eiffel is a great language. That was, who was that? Bernard, wasn't it? Bernard something who wrote that book?
Bertrand Mayer, yeah.
Bertrand Mayer, that's right. And he introduced the concept of class invariance and all of that kind of stuff. Good language.
Yep. So yeah.
But I think most of the time, the fact of it is we end up processing JSON more often than not in these applications, and that's where we spend, 80% of our time as developers, if we're going to be honest about it. So why not JavaScript? It's definitely the best language for processing JSON.
Yeah.
Yeah. Well, just about any language that I've ever even looked at has a well put together JSON library. So I think you're pretty safe there. So you set up the serverless, and then I can't remember exactly how AWS authorizes all this stuff, but you essentially, you just get your authorization for the AI systems or the machine learning systems, and then you just make the API calls, and that's it.
The permission model for each service is very, if you're familiar with permissions for buckets and so on, it's very similar permission model. All you do in your serverless YAML code is to make sure you give the appropriate permissions for the Lambda function to call the API in the same way you would with any other service, and off you go.
Now, one other thing that I'm curious about is, do you put the data processing in that same serverless function, or do you wind up having a separate process for that?
I suppose the answer is it depends. Sorry.
You guys really are consultants, aren't you?
We are, yeah.
How did you know?
It depends on your application, right, and the volumes of data and stuff that you're trying to work with. You can certainly. So I guess some of the APIs need to can work in a request response way. So you call something like recognition on an image. So you're pointing. Essentially, what you're doing is you're uploading an image to a bucket. You're pointing recognition at that image, and then almost immediately you're going to get a return back with your confidence and a set of labels on it. Let's say, right. So that can be done in line. For other things, let's say you have a larger document that you want to do some NLP analysis on, then typically what you're going to do is your Lambda function will trigger a more batch type API within AWS. So comprehend, which is the natural language service, will be triggered, and then you would basically wait for responses. So you might poll another API that says, okay, it's going to tell you how I'm processing, and then eventually it's going to finish, and then you take your results.
Yeah, that makes sense. That makes a lot of sense. How do you go about? Well, let me back up, because I guess the other thing is you could use something like Apache Spark, or you could pull together some other data pipeline system. Right, and then you have the cleaned up data, and then you can just hand it off, right? And then from there it triggers like we're talking about.
Yeah, like if you've got a kind of core system with Spark or something like that, then you can certainly employ Lambda around the edges.
Yeah,
orchestration and or interfacing to these API jobs.
Yep, absolutely. So how do you go about making sure that this stuff is secure? I mean, some of this is going to be like securing your serverless function like you would do on any serverless function, right? But are there any other concerns with this for security outside of just how serverless works?
I think generally with this model, using AWS with services like this kind of forces you into a more restricted, minimal privilege kind of pattern anyway. Unless certainly with IAM, with identity access management in AWS, you can allow star in terms of wildcard actions on wildcard resources, but that's clearly not the best practice, and minimal privilege is the better practice, as a lot of people doing anything on AWS will know. What it means is that you get very fine-grained access for each function, for each service it's trying to access, and because we're advocating for a serverless pattern anyway, every deployable service with its set of Lambda functions has a very clear minimal set of privileges for a very specific set of resources, which makes it much easier than trying to deploy, a monolithic application, which, has certain benefits for some people, but at the same time, trying to get fine-grained security and access control is much more difficult. Whereas, when everything is deployed as tiny fragments, really, you've got much more control. And then you just need to think about, I suppose, the security at the boundary. If you have a SaaS application with an API gateway at the front, then you need to start controlling web traffic, which is, its own set of concerns, but not unique to this use case. You need to be thinking about quotas and rate limiting and DDoS prevention, authorization, API keys potentially.
Been there, done that. Fun. Yeah. And then it makes sense, right? As far as this is a tiny, right? It's a serverless application. So it's just a tiny bit of JavaScript. It's very well-defined needs. And so, yeah, I'll just go turn those on and not turn on the rest of them in my permissions.
Yeah.
So what have you built with this stuff?
Good question. Fair bit, actually. We've done some fairly interesting stuff. Actually, we had to re-engineer something with recognition. That was quite an interesting case. So as we were starting to write this book, recognition, for example, wasn't available. And we had a client that was needed to do some it was working in the KYC space. So there was a need to kind of scan.
Back up just for a second. So I don't know if I'm going to say benefit, but I work for a company that is in the financial space. And so if you don't know what KYC is know your customer. And it's effectively, I had to go through all this training, and I'm a developer, right? So I don't even have to do KYC, but it's effectively use your tools and techniques to know who your customer is, what their business is, and understand what they're doing to prevent things like money laundering and stuff like that, right? So 99% of the people you're going to talk to and do the KYC work on, you're going to find out that they're exactly what they say they are, but they want to make sure that they are exactly what they say they are.
Exactly. Yeah. Sorry. Thanks for that, Charles. Anyway, this particular piece of the work was to recognize information from various documents like utility bills and so on. Now, when we started that, so Comprehend was available, but what wasn't available was Textract. So we actually had to go build using an open source OCR library, go and automate the scan of the document, do some math to pick out the bits and pieces in the document that looked the right shape, then feed those through our own recognizer to extract the required information. Then about 6 months after we did that, Amazon released Textract. So what took us, a good 6 weeks to put together could have been done in a few days.
Oh, wow.
But that's just an example of, if you haven't got a burning need, if you wait maybe 3 months, you might find that what you need is going to be released anyway, right? That's interesting. Maybe you want to talk about some of the IoT agritech stuff, Eóin.
Well, you guys work on fun projects.
Yeah, we do.
We do. We're lucky.
One of the interesting ones. So there's always another level down. So I suppose the question is, and people we get asked it quite a lot, is what happens when the managed services don't fit your use case exactly? And that's not an uncommon occurrence. These things are designed for general purpose image recognition. Recognizing faces in photographs, for example. But we do have a customer who had a very bespoke kind of agricultural IoT application where they had cameras out in the field measuring grass growth. And for that purpose, we collaborated with them building a custom machine learning model, which we then employed SageMaker to deploy. So SageMaker is an AWS service that allows you to deploy custom models, or actually you can go to the marketplace and pick a pre-trained model as well. But in this case, it was a trained model that was trained on a kind of on-premise infrastructure. So it was trained on a bunch of GPU machines. But then when it comes to deploying it, you don't necessarily need that bunch of GPU instances, and you don't want to be maintaining it or swapping out disks on it, or managing capacity. So there's a couple of ways you can do that. And the first way we approached it was to use SageMaker. And SageMaker allows you to just take that model, upload it to an S3 bucket. And then when you need an endpoint, you can just bring up a SageMaker endpoint. So you get a HTTP endpoint that you can post an image to, and it'll give you back an inference result.
Nice.
It'll give you back a measurement result. So that was really nice. And to be honest, that was a really interesting project to work on, and we were able to get that up and running in a week or two. Actually, it was very straightforward to do. But I think it's actually even easier these days, because one of the things we would have liked to have done at the time was just use a Lambda to run that machine learning inference, because it's while it's nice to play with these cool toys like SageMaker and these machine learning services, my favorite way to deploy any kind of code is with a Lambda function, because there's so little you have to do, and you can also scale it really instantly and really, really horizontally. So at the time, Lambda had certain restrictions around deployable unit size and memory size, but now for the last couple of weeks we've been able to deploy 10 gigabyte Docker images to Lambda.
Wow.
So
wow. That's awesome.
Exactly, right? I mean, I keep describing that as a game changer, but for applications like this, it really is, because Lambda doesn't do GPU yet. Lambda doesn't do GPU yet, but you don't for inference. Like when you're just uploading an image or a document and you're trying to get a score from it, Lambda is perfectly fine. And previously, you might have been constrained by the image, the 250 megabyte deployable code size. Well, if you can deploy a 10 gigabyte container, then you can run it locally, develop it locally, upload it as a Lambda function, and you can, get access to 10 gigs of RAM as well. So all of a sudden there's a huge amount you can do without even touching any of the machine learning specific services.
Right. So why is it 10 gig? Is that just all of the numbers you need that after having trained it to store all that, or is it something else?
There's the upper limit on Lambda now.
Oh, okay.
Yeah, for images. So if you're deploying a zip code as a zip, it's still 250 megabytes. Right? But if now you can just do Docker build. So for people who are used to using container tools and container images, you can do Docker build. They give you the tools to run those image-based Lambdas locally as well. But you upload them to your container repository, to ECR, and then you can run them from Lambda. And the runtime model is obviously very different to using Kubernetes or something else, where you're running typically something long running and it's responding to multiple requests concurrently. With Lambda, you're going to respond to single events. Every container just serves a single event at a time. But the fact that you can deploy 10 gigabytes of images, it's rare. I would normally struggle to come up with a way to fill that 10 gigabytes. But the fact that you can go up to 1 or 2 gigabytes makes a real difference, because some of these Python libraries especially are really heavy. You can get up to half a gigabyte pretty quickly. And I spent too much time in the past trying to, strip down.
I misunderstood. I thought you said you had deployed a 10 gig image, and I was like, wow, what do you have to put in there in order to need that?
Yeah.
But
I haven't built many models that are that size, but some people have. I think some of the examples I've seen of people have done close to 10 gigabytes, and they run in under a second, which is, I don't know how they do it actually, but I have done an example where I took an open source computer aided diagnostics algorithm that from GitHub for scanning chest X-rays, and the image size was about 2.5 gigs, but I was able to run 2,000 concurrent instances of it in a couple of seconds and go through hundreds of thousands of X-rays and get the results and pull those images from S3 and get the results into DynamoDB. And it was all done in under a couple of minutes. I think it was 90 seconds or something to process a record set that was hundreds of thousands of images. And, the beauty of that is, there's nothing there before you run it. 2 minutes later, it's all done and you still don't have anything running. So,
right.
I mean, that's great from a cost point of view and a flexibility point of view. But as a developer, it means that as you're iterating on that container image, you don't have to wait for clusters to scale up and scale down. You have immediate feedback on how well your code is performing. So if you need to run hundreds of cycles in order to optimize your algorithm, that saves you a huge amount of time. And developer time is, it's costly.
Yep. Yeah, I've had this discussion with people before where they're like, well, we'll just throw more infrastructure at it. And then somebody goes, well, that's going to cost us several thousand more dollars. And then somebody else points out, well, we go through that paying a developer for a week, right?
Yeah.
And this is saving us 3 developers. So, it's easily worth the cost. And so, yeah. I love the example. It's amazing when you really think about it, right? And what you would have had to do before something like this.
Yeah, we're really bad at considering that part of the equation intuitively.
Yeah,
at including developer time, because we kind of love to be busy and we love to be solving hard technical problems. That's kind of an instinct we need to kind of fight against.
Yep.
As if we can free ourselves up, then we can get rid of a lot of the firefighting headaches that we typically manage to create for ourselves.
Hey, folks, if you love this podcast and would like to support the show, or if you wish you could listen without the sponsorship messages, then you're in luck. We're setting up new premium podcast feeds where you can get all of the episodes released after Christmas 2020 without the ads. Signing up will help us pay for editing and production, and you can go sign up at devchat.tv/premium. Yeah, well, the other end of that is also that, at least in my case, I like tinkering with this stuff, right? And so it's like, oh, this would take me 3 weeks to do the other way. And it sounds like fun, right? But from the business standpoint, yeah, it's much better to pay me to spend my time working on the other problems that can't be solved in a matter of minutes on AWS.
Yeah, exactly. I mean,
sure.
The point is to focus on delivering the solution for the business, and not kind of all of this other stuff off to the side, right?
Right. So I guess the other thing that I'm wondering about is that I know that at least Amazon, they charge you for traffic, like for bandwidth, they charge you for storage, and they charge you for compute, so like how many processors and RAM and all that stuff you have on your resources. So we were talking about how cheap it is compared to developer time, but how do you keep the costs down when you're putting something like this together, right? Are there things that you can do to make it so that you can run as efficiently as possible?
Yeah, I mean, there are. I suppose the other thing to be aware of is that when you're using these machine learning APIs, there's a cost for using those APIs, right? So you'll build the model's a bit like Lambda in the sense that for Lambda you'll build for. I think you'll build at the millisecond interval for usage, whereas for each inference, you build for each inference. So if you call an image recognition, you'll build for that inference. It looks, and for things like comprehend, you'll build, I think it's per core, but also per volume of data processed as well. So, it's fine when you're doing it at small scale. If you're just running a few inference jobs, it's not going to be a huge cost. Just to keep an eye on those if you're starting to process these things at scale, because the costs will add up at scale, right?
Mm-hmm.
But even so, you're not managing your own infrastructure and so on. So typically the cost is pretty good.
Right.
Yeah. Sorry to cut across you, Charles, but yeah, it's something to be aware of. Understand the billing model before you get too deep into it, for sure. But just as we just said, compare it to your total cost of ownership and your developer time, and what's the alternative. If you're going to try and save money building your own custom infrastructure, because you got to take all the costs into account. But Peter's right; it's right. Built per unit, so some of these APIs can get seemingly very expensive if your data volumes and request volumes are really large. So at that point, it's worthwhile kind of taking a step back, looking at your cost comparison, and talking to AWS about how to keep that as low as possible, because if you're doing a Twitter scale image recognition on using an AWS service, then all of a sudden you're into something the average credit card on Amazon isn't gonna handle.
Yeah, that makes sense. But at the same time, what I find is when you get to Twitter scale, the other thing is that your concerns change, right? And so you're going to probably be focused on some things that are a little bit different from, what your AWS bill is, unless it's just way higher than you expected it to be.
Yeah, absolutely. I suppose the thing is just be cautious not to have stuff running away in the background that you don't turn off, right?
Right. Yep.
Now, typically that's going to happen with virtual instances or whatever, where you just get to turn stuff off. But if you've got a Lambda that's deploying, that's pulling stuff from an S3 bucket, and it's constantly processing it, just be cautious of those kinds of things.
Yep.
Yeah, and
absolutely.
always put billing alerts in place. So
Yes.
you at least, cost overruns do happen, and typically, they happen. If you're using AWS extensively, they happen from time to time. But the question is, can you spot them early enough so that they don't make really any kind of substantial difference?
Mm-hmm.
So if you're spotting them at the end of the day as opposed to at the end of the month, that's a massive difference. So yeah, there's a bit of groundwork to put in place there, but it's just good common sense to have those billing alerts in place, because we kind of have a fairly good understanding of the billing model from many of the services, but there's a huge amount of variation in there, and keeping it all in your head is quite difficult. So everybody needs I suppose an alarm bell that they can see going off, and that they can review things pretty quickly and scale things down as necessary.
I turned my video off because it's starting to get choppy, and I think it's my internet connection here. So
okay, should we do the same?
Yeah, that'll probably help. We're just about done anyway. So if you wanted to just kind of wrap all this up and pull all these ideas together, I kind of have a vague idea of how to do it, but you guys have been talking about this stuff and considering this stuff a lot longer than I have. So what's kind of the core message here? What's the core idea, and how do we pull all this stuff together for the listener?
Yeah, I guess the core message is that AI is no longer the domain of guys with PhDs. It's well within the scope of any developer who can call an API. So really, to be effective with it, we treat it as it's now an engineering problem, right? Mm-hmm. It's no longer a research problem. So it's more about application of the technology. And the quickest way to get up to speed and start applying this technology to business problems you might have is to start at the kind of service level. So make API calls. If that doesn't quite solve your problem, there's a middle ground. A lot of these services can be cross-trained. So that's a really important point, is that you don't have to go from, well, Comprehend doesn't solve my problem, therefore I need to go and employ a team of data scientists to solve my problem. There is a middle ground of actually cross-training existing services to fit your specific domain. So start at the kind of high make service call level, look at cross-training, and then if that still doesn't solve your problem, then you need to go back to services like SageMaker, where you train your own models. But it's all about looking at the business challenge, fitting a service or services to that problem, and then understanding and interpreting the results.
Great. Yeah, that makes sense. And it makes it sound so much more approachable than, kind of the PhD level stuff that I think a lot of people really do kind of put machine learning into, because it really wasn't that long ago where it was in that domain. Yeah,
absolutely. But, exponential technology growth and all of that, right? And I think over the coming years, we're just going to see more and more commoditization of AI, and more growth in the kind of range and capability of these services. So, as a piece of career advice, I'd really advise people to just get up to speed with some of these services, because the chances are sooner or later you're going to need to apply them.
Yeah, that makes sense. One other thing that just came to mind while you were talking about that, with the commoditization of things like machine learning or AI, it really came out when you said the exponential growth of technology. And it seems like, at least over the last few years, society at large has really scrambled to try and keep a pace with how we think about technology. And, with this exponential growth, it's just going to get harder and harder to do that. So how do we keep on top of what machine learning is capable of? And how do we start thinking about some of the problems that might be posed by some of the capabilities that are out there that may or may not have positive or negative repercussions for our society? Wow. I know I'm getting into philosophy now instead of technology, but I'm curious what your take is.
It's a huge question, right? It really is a huge question. And you're right, there are wide societal implications for this technology, right? And it's there have always been societal implications from technology, right? If you go right back to the Industrial Revolution, the Luddites were put out of work by the new milling machines or whatever it was, right? So that continues. Now, in the past, of course, what's happened is that the new technology has created new jobs just in a different shape and allowed people to kind of move across. I think this time it's a bit different, right? You're starting to replace. Previously you were replacing a lot of manual labor. Now you're replacing kind of intellectual labor, white collar type workers, right?
Mm-hmm.
So I think that's a different context, and it's a hard context to grapple with. And honestly, if you want to get deep into politics and so on, I don't think that our current economic models and ways of organizing society are actually fit to cope with the change right now.
Right. And it's interesting to talk about too, because we don't actually know where this is going to take us per se, right? I mean, you even look at what the internet did, when we're 25 years past sort of the wide adoption of the internet, and nobody could have predicted where it was going to go with social media, with the kinds of devices we're connecting with, and then how people use it and how that affects our society. I mean, I see people that I've known for years and years and years fighting with other people that I've known for years and years and years, or with me for expressing an opinion on Twitter or Facebook, that I never would have dreamed that they would be treating each other the way that they are, or that we'd be having the kinds of conversations about the kinds of things we're having conversations about because of the advances in technology. And that's just over 20-25 years. I think this is going to come upon us a whole lot more quickly, and I don't think anybody really knows what it's all going to mean and what it's going to lead us to. It may wind up being a breakthrough in an area that nobody's really even thinking about using technology like machine learning on right now, and that changes everything for everybody in meaningful ways.
Yeah, no, I think so. I think it's very hard to we can probably see 1 or 2 years out, but if you wind forward 10 years, the way that technology is growing, it is difficult to see. Ultimately, we still have our reptilian brains, right? And we still have each of us has this kind of emotional, reactive way of dealing with things, and as a society, I think we struggle to deal with these kinds of huge kind of sea changes. Just look at something like climate change, for example, right? A present threat to humanity, but something that we don't seem to be able to deal with, and maybe that's because we're more tuned to deal with immediate threats rather than kind of thinking strategically about threats to us. And I think it's probably similar with AI. All I can say is that the change is going to come. I don't think there's any way to stop it. And the reason I say that is because the ability to automate intelligence, and intelligence itself is the key value. It's so valuable to our societies that we're just not going to stop, right? And even if the more open societies were to try and put a limit on the technology, there are other societies that are perhaps not quite so democratic that would pursue the technology anyway. So I don't think Pandora's box is open. You can't stop it. What you can try and do is adjust the trajectory in flight to the benefit of all. But how you do that, I'm afraid, is probably a little above my pay grade.
No, I agree. And it's really interesting just from that standpoint. Yeah, we try and influence the trajectory to the best outcome. But the reality is that, these kinds of technological changes, I mean, even down to, you brought up the Industrial Revolution. Nobody really understood what it was going to mean until after it was over. And so we can try and steer the ship, but we don't actually know what the entire landscape looks like ahead of us. And if we turn, what we're going to be headed toward. So, we kind of hope for the best. I think most people who are working on this are working on it because they see the potential. And I think they're working on it for the good of humanity, or at least for the good of the industry or the good of the company they work for. But at the end of the day, yeah, it's going to have some far-reaching implications, and it's always interesting to dive into. But yeah, we don't really have time to go much deeper on this, but it's always so fascinating just to see where people are at.
It is. Why don't we come back in a couple of years and we can review?
Hey, there we go.
All right.
Yeah.
Hey, folks, I don't know if you've noticed, but I've been working a lot on figuring out how to help people become the most valuable developers on their teams or becoming the top 5% of developers in the field. If you're looking to level up, figure out how to contribute more, get the career you want, get the career that you want that will support the lifestyle you want, then you should check out the Most Valuable Dev Summit. I've invited some of my friends across the community, people that you've heard of, people that have worked on systems that you use on a daily basis, people who have invented new ways of doing things over the years in programming, and I've asked them one question, and that question is, how do you become a top 5% developer? How do you become 1 in 20 of the best developers out there? And so we're going to go ahead and have that conversation with them in interviews on the Most Valuable Dev Summit, and you can find that at summit.mostvaluable.dev.
All right, well, let's go ahead and get into picks. Now, I don't know if you had a chance to listen to the other episodes, but picks are essentially shout outs about things that you're enjoying or things that are making your life better or stuff like that, right? So we've had people pick like TV shows and movies that they've enjoyed or activities that they enjoy doing. Some people actually pick technology stuff because they're excited about it. So it really can be anything you want. And I'll go ahead and go first just so that we can, so you can get an idea of what I'm talking about here. One pick I have, and I think I've picked this a few times just because I've been listening to this book series since like September. And it's a book series that I listened to when I was in high school, or not listened to, I actually read them in high school. I've been listening to them on Audible now. And it's The Wheel of Time by Robert Jordan and Brandon Sanderson. And I'm on like the next to last book, so I had to throw in Brandon Sanderson because he had to co-write those last 3 books because Robert Jordan passed away. But yeah, I've really, really enjoyed these books, just fantasy novels in general. I'm sorry if I sound funny. I have a little bit of a cold. It's actually lingering stuff from COVID-19. So anyway,
feel better.
Oh well, I think I'm over it. It's just I still have a little bit of the congestion. So anyway, but yeah. So I've been really, really enjoying that. I've also picked up a few podcasts that I've really enjoyed. They're about podcasting. And so I'm just going to throw them out. I don't know how interesting they are going to be to most people, but just to put it out there so people can find them. I think my favorite one, honestly, is Changemakers with Jamie Atkinson and Gina Suzanne. And that's just a terrific, terrific show. They kind of get into the business of podcasting a bunch, and I enjoy that. Another one, I actually appeared on this show. It's the Podcast Domination Show with Luis Diaz. And then Podcast Talent Coach is another one. That's Eric Johnson. I interviewed all of those folks actually for my Podcast Growth Summit in December, but their shows are just terrific. And so if you're interested in podcasting, those are some to check out for sure. And then the last one I'm also going to throw out there for podcasters is the Buzzcast. And that's put out by Buzzsprout, which is one of the hosting companies you can host your podcast on. I think most of the technology folks have passing familiarity with Justin Jackson, and so they wind up going with Transistor.fm, which is another great solution for hosting your podcasts. And I think they have a podcast too, but I haven't actually listened to it. But I know the guys over at Buzzsprout, they do a great job, and their show, they really dive into some of the podcasting stuff, and the way that they look at podcasting is very in line with the way I look at podcasting. So I'm going to pick them. Actually, I should also mention that their CTO or director of engineering, I can't remember exactly what it is, Tom Rossi, was a panelist briefly on Ruby Rogues because their system's built on Ruby on Rails. So anyway, but yeah, I'll put links to all of those in the chat so they wind up in the show notes. And yeah, if you have any questions about podcasting and how it can help your career, I'm also just going to throw out that I am putting together some coaching for career planning. Typically, I'm looking at more senior folks, but if you want help planning your career and then building it up using podcasting and a few other tools that I'm putting together, then you can go to devchat.tv/next-level. And honestly, it's not going to be a sales call. What it really is going to be is just me asking you questions about where you want to end up and then kind of getting a feel for how we can get you there. So, because I don't actually have a product to sell there yet. So anyway, those are my picks. We'll put all those in the show notes, like I said. And Peter, why don't you go ahead and throw out some picks for us?
Yeah, sure. Okay. So I've recently been pretty fascinated with the Wolfram Physics project. I don't know if you're aware of that. So
yeah, cool stuff.
Super cool. So my background is actually physics. I did physics as my major, and I worked in fusion research for a number of years.
Nerd.
I know, sorry. There you go. But I stopped being in physics, a long time ago, and have been in engineering and software ever since. But it always struck me that there was, to get another layer down in physics was what was needed. And I hadn't seen any kind of really fresh thinking in it until I came across the Wolfram Physics project, which is Stephen Wolfram of Mathematica fame, whose view is that the universe itself is computational, and that all of the things around us are emergent complexity from very basic computational processes. And he claims that they're at the point of kind of deriving things like special relativity and quantum mechanics, or areas of quantum mechanics at least, from these low-level kind of computational simulations. So I'm actually fascinated by that, and I definitely worth checking out. My second pick is going to be physics as well. I'm a big fan of the PBS Spacetime channel. If you haven't seen it, it's kind of physics and the universe explained in a really kind of interesting and way that the kind of layman can pick up. So it covers everything from kind of warp drives down to quantum mechanics and stuff like that. So endlessly fascinating. My last two really quickly, 3 Blue, 1 Brown. If you haven't seen that channel, it explains concepts in maths, AI, data science really, really well, with really good animation. And then my final one is One Left of Center. I play guitar, and you know what? I haven't played guitar for a number of years. And then when COVID hit, I picked my guitar up again. And I picked up this channel, a guy called Troy Grady. It's called Cracking the Code. It's fascinating. And he actually goes in and looks in incredible detail at the actual mechanics of playing guitar. So that's really helped me improve my playing during COVID. So those are my picks.
Awesome. Owen, do you have some picks for us?
Yeah, I do. Actually, what I've got is a couple of kind of working from home ergonomics picks, because a lot of people may still be kind of figuring out their working from home setup. And about a year ago, I ended up in hospital with a back spasm, and I realized that kind of sitting down all the time isn't that great for me. So right after that happened, I was getting some physiotherapy and stuff. And I also decided to try out a sit-stand desk. So I on the recommendation of another fourth year guy, Greg, I got the IKEA Idison sit-stand desk. So this is a motorized, it's really rugged, stable motorized desk. And I've used it for almost a year now. And I found that it's made a massive difference. And, I just felt better in general. And I feel like I don't end up with kind of hip tension or any back problems since. So I definitely recommend that one. It's a bit of an investment, especially if you're paying for your own one. It's about $600, 500 euros, but it connects with Bluetooth to your phone and can measure how long you're standing up for if you're into that sort of thing. I definitely recommend that one. The other one I have is last week, actually. I've kind of, in the spirit of making kind of sporadic improvements to my work setup, I changed my keyboard. I found that I ended up with kind of wrist tension as well. I don't know if it's RSI or some kind of carpal tunnel, but I do get fatigue from using either my laptop keyboard or just a standard keyboard. So last week I took delivery of the Kinesis Freestyle 2 keyboard. I think a lot of people might be familiar with this one, but it's a split keyboard, and I also got the extension pack that allows me to tilt each half of the split keyboard up to 15 degrees, I think it is. So I'm still getting used to it. So half of my emails are full of typos at the moment, but I think it's definitely much more comfortable to use. So I'm pretty happy with that.
Yeah, makes sense. I'm going to just pile on that a little bit because I ran into that same problem for a while. I actually wound up with a giant cyst on my left wrist just from all of the moving my arm around, right? It didn't hurt. The doctor said that it wasn't dangerous unless it didn't go away. But I was also having actual pain in my forearms and wrists and hands. And then I would have numbness when I woke up in the morning in my hands. And it kind of freaked me out. And what I found is just the $3 foam keyboard bumper that goes in front of your keyboard to push your wrists up, and then wearing wrist braces at night solved a lot of that for me. When I went to the doctor, he also gave me a set of exercises that I could do just with like a can of soup, right, in my hand, and then just move it around certain ways and exercise or stretch it certain ways really helps. So if you're experiencing any of that stuff, I highly recommend you go to the doctor, because a lot of the stuff that they're going to give you is not invasive. It doesn't require surgery. They're not going to recommend that. And you can actually just go and solve a lot of that with some pretty inexpensive and easy to do routines. So, yeah. Anyway, and I love my sit-stand desk, but I'm going to let yours stand. I'll pick that on another show.
Okay. Yeah, I'm interested to know, but yeah, I'm really happy with this one.
Good deal. All right. Well, once again, if people want to connect with you guys on the internet, where do they find you?
You can find me on Twitter. I'm Eóin S, so EOINS.
All right, Peter?
You can find me on Twitter at Pelger, Pelger.
Awesome. And we'll make sure that those wind up in the show notes too, so people just click through and follow you. Thanks again for coming. Great. This has been really terrific. And it's been a little bit different flavor, I think, than a lot of the other shows where we're actually digging into like the deep bowels of how these algorithms and stuff work. But at the same time, I feel like this makes it really approachable for people, because it's like, I don't have to be a genius to get into this. I can just go implement something interesting or fun or something for work. And at the end of the day, I can use the skills I have, and then I can go deeper as I need to.
Yeah, hopefully your audience find it interesting. You know, it's for us, it's been fascinating to write the book. It's always hard work, right? But ultimately, we really enjoy doing it. You know, and if it helps people to move their careers forward and get on with this technology, then so much the better.
Yep, absolutely. All right. Well, thanks again. We're going to wrap it up, and until next time, folks, max out. Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more.